Okay, so here I'm testing sort of the left sloppy side of the bisection algorithm. And so I know what being tuned too tight is, but I need to understand what being tuned too sloppy is. And so conveniently, the integral term in the automated routines is just set equal to the proportional term. So I'm just playing with the D term and the P term, and I can set some methods. You just tune the D term first, and that is what the code does for the automated routines. And you're just looking for oscillation, and that gives you like as much snappiness as you can get. And then once D is as high as it can be, then you can increase P. And then once you're within the right zone, you can kind of play them both together. And so when I'm doing the tuning here, I'm looking at the far right of the drone, like the very edge of the right lift module. And you can imagine that point on that edge being like on the PID graph. And so I'm visualizing like the optimal PID graph in my mind as I'm doing this tuning. And so I want one oscillation, like one overshoot with then going right down to the set point. And so some of these points you can see that it's it kind of goes past. It's not tuned as tight as other parts of the video. And we do have there's a blog article that kind of goes into the details of PID graphs, so you can look at that. So what's different about this tuning, which is counterintuitive, like normally you'd have to look at logs and data to see like what the PID behavior is. In this case, you can observe it directly, like with your eyeballs, because it's happening in real time, because the moments of inertia are high enough that like your eyes are the sensor, and it works, and that's really all you need. And so it's just a case of, a lot of times in engineering, it can be easier than you think it should be. Like the genetic algorithm for this, at one point I figured out, well, you just plot everything on a graph, and that's all you need. You don't have to code a bunch of stuff. And so the stand oscillates left to right slightly. That you kind of have to factor that out. You're looking for the sort of up-down motion of the right lift pod. And so I'm doing really small choppy movements and along with kind of bigger ones. And so I'm looking to see that as soon as I let go of the stick, it just sticks to exactly where I left it. And as it goes along, you can definitely see that it's getting tighter to the point that it's hard to point out, like in a video, what actually was going on. But what I was doing is I had a knob on the transmitter that has like the P value or the D value, and to the far right I set where I know it's too tight, and on the far left I set like the initial value I flew for the 2-hour test flight. And so it's tuned a lot tighter than that initial test flight. And so I'm going all the way left on the knob, all the way right, and then seeing what happens. Then I go in the center, and then based on kind of how it behaves at the center of the knob, then like, well, is that too sloppy or is that too tight?